All right, completing the square. So this is a method that we can use to solve quadratic equations. So let's do a quick recap. If I have x plus 3 squared, we've got this binomial squared. That's the same thing as saying x plus 3 times x plus 3. And in order to expand this, we would just need to double distribute x times x times 3, and then of course this 3 would get multiplied to the x and also to the 3. So expanded, this would be x squared plus 3x plus 3x plus 9. All right, and then of course, hopefully you recognize that these two middle terms are like terms and we can put them together. So we've got x squared plus 6x plus 9. So if you ever see a trinomial and you notice this c value, the constant, if you can take its square root and then double it and get this b value, this middle term, the coefficient of x, then you've got yourself a perfect square trinomial. Okay? So let's do some practice problems. If I have ax squared plus bx plus c equals 0. So we've got x squared minus 6x minus 11 equals 0. In this case, our a value is 1, our b value is this negative 6, and our c value is the negative 11. So the first thing I want you guys to do is divide all of your terms by your a value, your x squared coefficient. But in this case, our a value is a 1, so that doesn't change anything for us. So we can go ahead and move on to step 2. Step 2 is to move the constant to the opposite side of our equation. So that c value, that minus 11, we'll add to both sides of our equation. And that ends up giving us x squared minus 6x equals 11. Now I purposefully left a gap right here where the minus 11 and plus 11 canceled each other out because we're going to add something to it. So here is your third step. This is what I want you guys to do. You are going to take your b value, you're going to divide it by 2, and then square it. So in this case, our b value was negative 6. So we're going to take negative 6, we'll divide it by 2, and then square it. Negative 6 divided by 2 gives us negative 3, and negative 3 squared gives us a positive 9. So we're going to add 9 to both sides of this equation. Now, why did we do that? Because what we just created was a perfect square trinomial. The square root of 9 could either be a positive 3 or a negative 3, right? And if you can see right here by our b value, if we took negative 3 and we multiplied it by 2, we would end up with negative 6. So that perfect square trinomial always factors into this pattern right here. It's going to end up being a binomial squared. Our variable is x. And then whatever b divided by 2 was, in this case, negative 6 divided by 2, that gives us a negative 3. That's what goes inside our parentheses also. It's a minus 3. And then on the right side of our equation, we have 9 plus 11, which gives us 20. All right? So we're a lot closer now than we were before. Now we just have x minus 3 squared. Well, the inverse of the exponent squared is just your square root. So we take the square root of both sides, and the square root and squared are inverses. They undo each other. So we are left with x minus 3 equals plus or minus the square root of 20. Now we can simplify the square root of 20 because its factors are 4 times 5. And the square root of 4 is just 2, right? If we were to break down the number 4 even further, it would be 2 times 2. So the only way you come out from under your square root is if you have a pair of numbers. So the right side of our equation is just plus or minus 2. They come out as a pair. And we have the number 5 left over. It does not have a pair. And then, of course, the left side of our equation was just x minus 3. Okay, so we almost have our x value by itself. Let's add 3 to both sides of our equation. And that ends up giving us x equals 3 plus or minus 2 square root 5. Generally, that's the format that we're going to write it in so that we can tell the 3 is definitely not underneath our radical. We wouldn't place it behind here. It just looks a little neater and cleaner when we write it in this order. Okay, let's try another one. We have negative 2x squared plus 4x minus 8 equals 0. Divide by your a value first. Divide your entire equation, every term, by negative 2 so that it stays balanced. And we end up with x squared minus 2x plus 4 equals 0. Okay? Then our next step is to move our c value to the other side. So we would subtract 4 from both sides, and I'm just going to save some room here. That gives us x squared minus 2x equals a negative 4. All right, now our next step, we've got to complete the square. Let's take that b value, cut it in half, and then square it and add it to both sides. Negative 2 divided by 2 is negative 1. So this is saying negative 1 squared, which is a positive 1. So we'll add 1 to both sides of this equation. So we've got our perfect square trinomial right here. And its factors, we just have a binomial squared. It ends up being x, and our b value divided by 2 gave us a negative 1. So we have minus 1 right there. And then, of course, the right side of our equation, negative 4 plus 1, is just negative 3. All right, so we've got x minus 1 quantity squared. So let's get rid of that exponent squared. And let's use the inverse square root. And when we take the square root of both sides, again, square root and squared, they undo each other. So we're left with x minus 1 equals plus or minus. Now let's go ahead and simplify the square root of negative 3. So the square root of negative 3 is the same thing as saying negative 1 times 3. And hopefully you remember your imaginary numbers. The square root of negative 1 is always I. Comes out as an I, the imaginary I. And then we have the 3 left under our square root. So it's just I square root 3. All right, subtract 1 from both sides of your equation. And this ends up giving us x equals negative 1. Oh, I'm so sorry. That should have been a plus 1. Go back. The inverse of this minus 1 would be plus 1. I'm glad I noticed that. Add 1 to both sides of our equation. And this would end up giving us, oops, that was too big. That would end up giving us 1 plus or minus I squared of 3. And there's our solution. In this case, we have two imaginary solutions to our quadratic equation. And that really would have ticked me off if I hadn't noticed that before I went on. All right, problem number 3. 3x squared minus 9x minus 12 equals 0. All right, so let's divide all of our terms by 3. Get our a value equal to 1. And that ends up giving us x squared minus 3x minus 4 equals 0. And then we'll move our constant to the other side by using its inverse operation. We'll add 4 to both sides. That gives us x squared minus 3x equals a positive 4. And now let's complete the square. Our b value is a negative 3. Divide that by 2, and then square it. Well, in this case, negative 3 divided by 2 is as simplified as we can get. That doesn't turn into an integer value, right? So negative 3 divided by 2 squared is just negative 3 times negative 3 over 2 times 2. So negative 3 times negative 3 is 9. 2 times 2 is 4. So we're adding 9/4 to both sides of this equation. All right? So our perfect square trinomial right here can be rewritten as a binomial squared. So we've got our x value. What was b divided by 2? It was a negative 3/2. So we're going to put minus 3/2 right here. I know how much everybody loves fractions. All right, so we have 4 plus 9/4. I need a common denominator. So I'll put this as 4 over 1. If I multiply the denominator by 4, I end up with a 4, which means I need to multiply my numerator by 4 also and get 16. So 16 fourths plus 9 fourths gives me 25 fourths. All right, and now I can take the square root of both sides of my equation. When I do that, my square root and my squared terms cancel out, and we're left with x minus 3 over 2, equals plus or minus the square root of 25 over 4. All right, so the square root of 25 over 4 is the same thing as saying the square root of 25 over the square root of 4. And of course, the square root of 25 is just a 5, and the square root of 4 is 2. Oh, and we really didn't need our parentheses anymore. I'm not sure why I put that. I must be getting tired tonight. So we have x minus 3 over 2 equals plus or minus 5 halves. All right, so let's add 3 halves to both sides of our equation. And because we have like terms here, that makes our life easier. We end up with x equals 3 halves plus or minus 5 halves. And we do have a common denominator in this problem, right? Both of our denominators are 2, so we can rewrite this as x equals 1 giant fraction, 3 plus or minus 5 all over 2. And that's how you can use completing the square to solve your quadratic equations.